Good afternoon, everyone, and welcome to Simplifying the Migration of IoT Applications to AWS IoT. My name is Jared Sharfin, Senior Product Manager with AWS IoT Core, and with me is Max Jindal, Senior Software Development Engineer for AWS IoT Core. So to start out, I'd just like to quickly review the agenda for this presentation. We'll start off by diving into some of the challenges that customers face when building applications at the scale of IoT. We'll then dive into how AWS IoT Core is helping customers address these challenges with a new feature called Configurable Endpoints. And finally, we'll see a live demo of Configurable Endpoints working in action to solve a real-world problem. And then at the end, Max and I will make sure to stick around for a couple minutes to answer any questions that you guys may have about Configurable Endpoints. So let's kick it off by looking at some of the challenges that customers commonly run into when building IoT applications. So the world of IoT is vast and diverse, and IoT actually spans many industries, ranging from healthcare to agriculture, with use cases like precision agriculture and connected combines, connected factories, connected vehicles, smart cities, oil and gas. Pretty much any industry that you can imagine is touched by IoT. And in fact, the world of IoT is continuing to grow bigger and bigger, and this is because the costs of connecting devices are continuing to come down. We see the advent of new communication protocols like NB-IoT and LoRaWAN, making it cheaper than ever to connect your devices to the internet. And in addition, devices themselves are becoming cheaper than ever to build. So you have fully integrated systems on a chip with CPU, Wi-Fi modules, security libraries, everything that you need, costing single-digit dollars. In addition, these new communication protocols and these new systems on a chip are consuming less and less power. So you can put smaller batteries on your devices, further reducing the BOM cost to build them. And as a result, we're seeing the number of connected devices skyrocket, with analysts estimating that there are tens of billions of devices connected today. But what customers are finding is that building IoT applications is actually a little bit different than building a typical web application. For one, traditional web communication paradigms, things like client-server, request-response style messaging paradigms, don't necessarily fit ideally with IoT. For instance, in a client-server model, clients are creating requests, servers are serving these requests, but servers are unable to send unsolicited messages down to a client. And this doesn't really work that well for IoT when you may want to have your devices sending telemetry messages to your backend application, but you also want the backend application to be able to issue command messages down to your devices whenever it wants. In addition, IoT applications often require the use of lightweight protocols, so protocols lighter than HTTP, things like MQTT. And this could be because your devices are resource constrained, or it could be because they're operating on constrained networks or networks where you're actually paying for bandwidth, things like cellular networks. And finally, IoT applications need to be able to handle massive scale, often handling hundreds of thousands or even millions of concurrently connected devices. And these requirements are presenting some new and interesting scaling challenges. The first is load balancing. So if you're using these bidirectional communication protocols, they often require persistent connections. And these connections might last for hours, days, weeks. And during the duration of the connection, these devices are pinned to a back-end host on your application. So how do you load balance this? The second is horizontal scaling. These stateful protocols like MQTT have complicated data structures for managing all the routing information and connection state. How do you shard this horizontally and scale your fleet horizontally to manage the growing loads? And finally, how do you do all of this at scale? As your device fleet grows to hundreds of thousands or even millions of devices, how do you maintain performance of your application? So what we often see is that customers start out with an architecture that looks something like this, where they have some self-managed connectivity and messaging layer, often something like an off-the-shelf message broker, that's taking all the device connections and then fanning the device traffic out to the appropriate application component. And really this top part, this is kind of like the secret sauce of your application. This is where all of the domain-specific application logic, like what makes your IoT application an oil and gas well monitor, or what makes it an asset tracking solution. All of this is kind of the top layer application components. But what we're seeing is that as device traffic grows, the connectivity and messaging layer is actually the hardest part to scale, and where customers are ending up spending most of their engineering time and effort. And this really kind of detracts from allowing customers to be able to focus on what makes their application unique. And this connectivity and messaging layer has to work, and it has to work reliably at scale. So this kind of undifferentiated heavy lifting is ripe for offload to an AWS managed service like AWS IoT Core. And in fact, IoT Core has solved a lot of these scaling challenges that we mentioned earlier. So the need for bidirectional event-driven communication, IoT Core offers this as a fully managed service, meaning no provisioning of capacity, no scaling or managing any infrastructure, the use of lightweight protocols. So AWS IoT Core supports MQTT 3.1.1, PubSub protocol, that's an ISO standard for IoT communication, and a large volume of messages and connections. Totally check. IoT Core is capable of handling tens of millions of concurrent device connections with hundreds of thousands of messages per second per account. But there's still a problem. How do you take your connectivity and messaging infrastructure and move it over to IoT Core while maintaining a consistent interface for your devices to communicate? And this is a problem because it's much simpler to update backend application software than it is to update device-side software, for instance, to handle a new interface like a new endpoint or a new authentication mechanism. And the reason for this is devices, first of all, may not be on when you want to update them. They might be hard to reach. They might not have OTA update capabilities. Or in the case of a multi-tenant application, you might not even control the end devices. It might be your customers, and you'll have to ask them to opt into a software update. Really, this gets at the root of the problem, which is it would be ideal if the migration of your messaging and connectivity to infrastructure to AWS IoT Core was totally transparent to end devices. Unfortunately, IoT Core now has a solution for this. I'd like to introduce you to a new feature called Configurable Endpoints. So configurable endpoints enable you to kind of customize the behavior of your IoT Core endpoints. So this means adding things like a custom domain to ensure that your devices can continue to connect to the same fully qualified domain name that they were using previously, and attaching a custom authorizer to your endpoints to enable you to handle whatever kind of authorization and authentication scheme you were using before. So these two configuration options are available today, and also in the near future, we will enable certain TLS configurations on your endpoint. So this would be things like minimum TLS version to support, or which cipher suites to support. For instance, if you wanted to ensure that only elliptic curve cipher suites could be used on your endpoints. Or also, even things like enabling and disabling certain TLS extensions, for instance, things like maximum fragment length negotiation. And what configurable endpoints really enables you to do is maintain this consistent interface for your devices as you transfer your infrastructure to IoT Core. So in this example, maybe devices were using MQTT username and password to connect, and they're connecting to broker endpoint iot.foodcorp.com. After the migration, they can continue to use this same endpoint, same authorization and authentication scheme. Migration is totally transparent to devices, ideally requiring no device software updates. So let's dive in a little bit to see how this works. And actually, there's only a couple steps to set it up. It's pretty quick end-to-end, and we'll go through each of these steps. So the first step is really to just ensure that your devices are capable of using the requisite TLS extensions to communicate with a configurable endpoint. Namely, they'll need to use SNI, server name indication, and ALPN if you're using a custom authorizer. So this is application layer protocol negotiation. And we'll have a quick recap of what these two extensions do. So server name indication is a standard TLS extension. It's defined in RFC 6066. And it's really designed to let clients communicate to the server what host name they're trying to reach. So as the device connection request is going through various layers of DNS translation, so you can see in this example, going from iot.foodcorp.com to a customer's Amazon-issued AWS IoT Core endpoint, and ultimately to the IP address of our service, the IoT Core is still able to recover the original host name that the device is trying to reach. And what this enables us to do is ensure that we are serving the proper server certificate for your custom domain. So the second extension I mentioned was application layer protocol negotiation. And what this does is, during the TLS connection, it enables the device to signal to IoT Core which application layer protocol it's going to be using. to communicate, and enables IoT Core to queue up the proper authentication scheme for that application layer protocol. So you can see in this example, in the first example, device says I'll be using HTTPS, so we know to queue up the SIGV4 authentication path. Or alternatively, a device could say I'm going to be using MQTT, and as a result, we'll delegate to your custom authorizer for use in parsing the MQTT username and password to authenticate. So you want to ensure that your devices are capable of using both of these TLS extensions. And I'd like to point out that if your devices are using our V2 device SDKs, those SDKs have support for these two extensions built in by default. But if you're not doing that and you want to just ensure that your devices are capable of using these extensions, you can actually do that pretty easily with a quick packet capture. So all you'd have to do is run a packet capture, put on an SSL filter, look for the client hello message in the TLS handshake, and then just look for these various extensions. So in the case of server name indication, I know it's a little bit difficult to see, but you can see highlighted here, we found this extension. Device seems to be, looks like trying to communicate to the SNS service. Same thing goes for ALPN. You can also check this with a quick packet capture the same exact way. Here you'll just be looking for the application layer protocol negotiation extension. And in this case, it looks like the protocol value that it sent was HTTP 1.1. So once that's all set and you've ensured that your devices are capable of using the requisite TLS extensions, you can go ahead and register your custom domain and the associated server certificate in AWS Certificate Manager. So you can either import your own certificate into Certificate Manager, or you can request that AWS Certificate Manager generate a certificate for you. In either case, the second step will be that ACM will try to do a domain ownership validation just to ensure that you actually own the domain that you're requesting or importing a certificate for. And there's two options for this. The first is what's called email validation. So this is basically ACM will send an email to the postmaster email address on the domain, and it'll have some kind of confirmation message that you click. And the second and kind of easier and more preferred method is what's called DNS validation. So in this path, ACM will give you basically a random subdomain on the domain that you're trying to register, have you set up a CNAME record with your DNS provider to another random string .acmvalidation.com. And then after a couple of seconds, they'll try to send a payload to this random subdomain that they gave you and ensure that they're actually able to receive it on this other ACM validation endpoint. And by that mechanism, by ensuring basically that you control the DNS records for that domain, they validate that you own the domain. So once you have your certificate all registered and your domain set up, you can go ahead and create a custom authorizer that you can use, and this is in the case that you'd like to do something like MQTT username and password auth, or some other authentication scheme other than TLS mutual auth. So to do this, you'll just create your Lambda function that you'll be using as your authorizer. Then you'll attach it to a custom authorizer object. And I'd like to point out that when you're using custom authorizers with configurable endpoints, we actually have a little bit of enhanced functionality. So you'll no longer need to have your authorization or authentication token signed by a private key. And this is because obviously in the case of a username and password, the password's not going to be signed by any key. And so we enable you to set up your authorizer with this signing disabled parameter. So that means you'll be sending some kind of credentials that are not signed by any key that the authorizer has. So once your authorizer is set up, as a final step, just ensure that you are granting Lambda invocation permissions to IoT Core. So basically, you'll just run this Lambda command to add permissions for the IoT service principal. And all this does is ensure that IoT Core is able to call your Lambda on your behalf when you're trying to connect new devices or when your devices are trying to send messages. And one other thing I'd like to point out about custom authorizers is I mentioned briefly that when you are using custom authorizers in combination with configurable endpoints, there's a little bit of enhanced functionality. So you can kind of see that here. Previously, when you were using custom authorizers, the only context that your Lambda would receive in the triggering event from IoT Core was this token, the element in blue up here. But now, with custom authorizers for configurable endpoints, you'll receive a much richer set of connection context information from which you can make your authorization and authentication decisions. So you'll get all this kind of rich protocol data. So at the TLS layer, you'll be getting information on the server name indication string that the device was sending. If you are using HTTP publish or MQTT over WebSockets, you'll also get some of the information from the HTTP headers. So you'll get all the header information. You'll also get actually all the query parameters. So now you can embed your credentials in either a custom header or a custom query parameter. And in the case that you're using an MQTT-based connection, so this is MQTT over TLS or MQTT over WebSockets, you'll also get additional context from the MQTT connect message. So you'll be getting the username field, the password field, as well as the client ID. And you can use any and all of this to make your authorization and authentication decisions. And as previously with custom authorizers, your Lambda just needs to return a valid IoT policy document. So once you have your authorizer all set up and your domain all registered, you can go ahead and create this domain configuration object. So this is the configurable endpoint. And to do this, we've introduced a new API that's called create domain configuration. And it just has a couple little attributes that you need to pass. The first is a configuration name. So this is just like a handy label by which you can remember which configuration this is and what it's doing. Then the domain name that your devices will use to connect on this endpoint. So you can either leave this blank and have us generate an additional IoT Core endpoint for you, or this is also where you could put in your custom domain. And if you're putting in a custom domain, you'll also have to put in the ARN of the certificate that you registered in ACM. Additionally, optionally, you can attach your custom authorizer here. So you'll just put in your authorizer name from the authorizer that you created in step 2. And this will be the default authorizer for your endpoint. You can optionally enable authorizer override. And what this lets you do is enable the device to specify an alternate authorizer that it would like to use other than the default authorizer. And finally, you'll put in the service type. So this is actually kind of reserved for future use. In the future, you'll be able to create configurable endpoints for your IoT data endpoint, your IoT credentials provider endpoint, and your IoT jobs endpoint. For the beta, we actually just support your IoT data endpoint. So this is the endpoint that your devices would connect to send like telemetry messages and things of that nature. So the final step is once you set up your domain configuration, you can set up now your DNS records that will map your custom domain to your IoT Core endpoint and allow you to send traffic on the custom domain to the IoT Core service. So the important thing to point out here is you'll need to make sure that you are CNAMing to a new endpoint type that's called data beta. And you can get your beta endpoint by just running the standard AWS IoT Describe endpoint API and running this with an endpoint type of IoT data beta. So this will generate you this beta endpoint, and you can immediately recognize that because the first subdomain will end with a -beta. So just ensure that you're setting up your CNAME record to forward traffic to a beta endpoint, and that will allow you to use your configurable endpoint. So the final step is once everything is set up, just make sure your devices are all configured, and go ahead and connect them to your configurable endpoint, and you should be receiving traffic in IoT Core. So now we'll actually go to a live demo to show you how this works in practice. And the scenario that we have set up here is that we have a fleet of devices that are connecting to our self-hosted broker on an endpoint, in this case, mqtt.awsIotrocks.com. And these devices want to authenticate to this broker with username and password. And we want to be able to migrate this kind of messaging and connectivity portion of our application to IoT Core without changing this interface for devices. So we'll just run a quick demo right now. Sorry, computer just went to sleep. So the first thing I'd like to show you is the first step, which is actually registering our certificate in ACM. So if I just go to the Certificate Manager console, we'll see I have a couple certificates registered, and the first certificate I have is actually a star certificate on the AWS IoT Rocks.com domain. So this will be valid for all like first level subdomains of AWS IoT Rocks.com. And we can see that the certificate has been issued and that it's in use, which means that IoT Core or some other AWS service is actually picking up this certificate. So, okay, so that looks totally good to go. The next thing I'd like to show you is our Lambda for our custom authorizer. So here, we've set up this cool Node.js reInvent demo Lambda. And what this is doing is actually looking in this JSON object that we're passing as the event trigger to your Lambda, picking out the username and password field, base64 decoding the password, and looking for a password called test. If it finds a password called test, it'll issue a ** policy. Otherwise, it'll issue or allow ***. Otherwise, it'll issue a deny ** policy. So we can actually look at this really quick. We have this test event configured. This test event is just sending the same JSON blob I showed you earlier with all this rich protocol data information. And it's in the password, this is just base64 encoded string test. So we'll pass this. We'll run a quick test with our Lambda. We'll see what it did. Cool. It generated a ** policy allowing all IoT Core operations. So this looks good to go. We'll attach this Lambda to our custom authorizer. So if we actually look, we have a couple. It looks like I have a couple authorizers configured. reInvent demo authorizer. This is the one I'd want to use. So we'll just take a closer look at what's actually in here. So we can see that I've attached the ARN of my Lambda that I just showed you. And the other thing I'd like to point out is that signing disabled is set to true. So this is what I was mentioning before. Since we want to use this authorizer for MQTT username and password authentication, there's not going to be any kind of like token signature or any kind of signature at all on the password. So we don't want any signing. So we've set that to disabled as true. So the next thing is to set up our domain configuration. So if we look, we have a couple of domain configurations all set up. Actually, by default, IoT Core has generated domain configurations for an IoT credential provider endpoint, a data endpoint, and a jobs endpoint. And then I have a couple custom ones set up. So I have this domain configuration named reInvent set up. So this is our demo configuration. So we'll take a closer look at what's actually in that one. Okay, so here we can see that I've given it the name reInvent, and it's set up to use a fully qualified domain name, mqtt.awsiot.rocks.com. So this was previously the endpoint of our self-hosted broker. In addition, we've attached our server certificate that we registered in AWS Certificate Manager. This is just the ARN of our certificate. We've also attached our custom authorizer. We don't have any authorizer override, so we'll just be using the default authorizer in this case when devices connect. Our domain configuration has been enabled. It's for our data endpoint, and this is using a custom domain, not an IoT Core generated domain. So as a final kind of sanity check before we go ahead and connect our devices, we'll just do a quick dig on our domain name and make sure that all the DNS records are set up properly. So we do this. Okay, awesome. Looks like I can see a CNAME record. We're actually CNAMing to our beta endpoint. So this looks like it should be good to go. And just actually as one last sanity check, just to make sure everything is working properly, and actually because it can take up to 15 minutes from when you create your domain configuration for your server certificate to flow in through from ACM to IoT Core. You'll just want to wait a few minutes and then maybe just run something like an S-client command to make sure that you're getting the appropriate server certificate on your endpoint. So in this case, we'll connect to mqtt.awsiot.rocks.com with the show certs flag, which just means we'll get the certificate chain that our endpoint is vending. We'll also with this server name flag, which just sends the server name indication extension, and we've set it to be the same as the fully qualified domain name that we're trying to connect to. So if we do this, okay, well, we got a certificate chain, so that's a good start. And if we kind of traverse up the chain, so starting at the bottom is the root. The top will actually be the leaf certificate or the server certificate. We can see, OK, awesome. The server certificate that we're getting has a common name, star.awsIotrocks.com. This is exactly the certificate that we registered in ACM. And you can see, since we actually didn't import a certificate, we had ACM generate a certificate for us. It's using the Amazon CA, which is called Amazon Trust Services. So this is signed by Amazon Root CA1, which is in turn ultimately cross-signed by Starfield, which is another big CA. And this is just important because if you're having ACM generate your certificates, that means you'll want to use Amazon Root CA1 as the root CA on your devices when you're connecting to your custom domain. So this looks all good. Let's give it a whirl. So we just have a simple Python script that's using our Python v2 device SDK setup. And so what the script is doing is it's taking an endpoint argument. So we've put in what was previously our self-managed broker endpoint. We've given Amazon Root CA1 to validate the server cert. We are connecting on port 443. We're sending our ALPN string set as MQTT, so IoT Core knows that we'd like to use MQTT username and password auth, and we'll apply our custom authorizer. And finally, we've set the MQTT username and password to be test. So this should, if you remember from our Lambda, generate a star policy that allows us to do anything. And the thing I'd like to point out is you'll note that we're not sending any client cert here. So we're the only kind of authorization credentials that we have are the MQTT username and password. So actually, really quick, just to make sure that I'm not trying to fool you, we'll go to IoT Core. We'll just go to the test MQTT client that they have. And we will subscribe to pound. So this should just let us see all the traffic that's flowing through to the broker. So let's give this a whirl, run it. OK, looks like it's sending a couple messages with the payload hello world on topic sample test. Let's see what we got. And it's actually, you can see, it's connecting to our custom domain, not an IoT Core domain. And let's see what we got. Fingers crossed. All right, awesome. It looks like we're actually receiving the messages in IoT Core that we sent on this custom domain. So everything looks like it's working. You've seen an end-to-end demo now that's using a custom domain with username and password auth. And actually, that concludes our demo. So I'll flip it back really quick. At this point, I'd like to open it up to questions, and this concludes our presentation. So thank you all for showing up. And Max and I, as I mentioned, we'll stick around for a couple minutes to answer any questions that you might have.